Suppose you wanted to know how many pieces of candy are in a standard size bag of a certain candy, the distance people in a certain town commute to work, or the number of hours students spend on homework. What would you do to find those values? Well, if we just look at the distance people in a certain town commute to work, I think most people would say it would make sense that you would ask somebody that works how far they commute to work. So the distance they commute to work. And that will be an excellent start of how to figure out how far on average people commute to work. If you just ask one person compared to 2 people or 3 people or 4 people, this is what question 2 gets into. Which would be stronger evidence to estimate people's commute distance to work? You're told the sample of 50 people had a mean commute distance of 8 miles, or you are told one person had a commute distance of 8 miles. So which would you think is stronger evidence to support the mean commute distance being 8 miles? Well, most people would logically think that the more people you ask, the better your estimate will be, or the stronger evidence your estimate is going to have. So the 50 people having a commute distance of 8 miles will be stronger evidence than just if one person had a commute distance of 8 miles. So why is that? Well, that's the next paragraph. We know that because of variation, only taking one item from the population may give us a value that is not representative of the population. For example, just by chance, you may choose the person who commutes a very long distance to work every day, or the person who just lives down the road a short distance from their workplace. It is also possible that the one person you chose commutes the same distance as many others. So the person you choose may be way below the average distance that people travel, maybe way above the average distance for everybody, or it could be right on the money. Okay, it could be exactly the same distance on average that everyone else travels. Okay, so only taking one from the population, there's a lot of variation in that distribution. So this is why we need to take a sample of individuals or items from the population rather than just one item or individual. Recall that when we repeatedly take samples of size n from a population, we can form a sampling distribution to sample means, the SDSM. So the concept is that we do not know our population parameter. Okay, so now the whole idea with confidence intervals is going to be that we do not know what the population parameter is. So on average, how many candies are in all bags? That's the population parameter, the average mu for the population of all bags of candy. On average, what is a commute distance for people, for all the people in a town? So that would be mu, the average commute distance for the population. On average, how many hours do all students spend on homework? So there the population parameter is mu, which is the average number of hours all students spend. Okay, so what we'll do is we can estimate the population parameter, in these cases the population mean mu, by taking a sample of size n and then applying the theory of the sampling distributions in the central limit theorem. Okay, remember that the central limit theorem told us the mean of the sample means was equal to the mean of the original population, and the standard deviation of the sample means is the population standard deviation over the square root of n. Okay, and then also we want to have a large enough sample size, so n has to be greater than or equal to 30, or your original population had to be normal. So that's what the central limit theorem is telling us.